In the grand tapestry of human endeavor, there are, honestly, just a few creations that rival the sheer scale and ambition of the great dams. These are not merely walls of concrete and steel, they are monumental testaments to our ability to reshape the very landscape, to tame the immense power of the world's mightiest rivers. Today, we embark on a journey to explore the 10 most powerful of these titans, ranked by their installed hydroelectric capacity. These structures are more than just power plants. They are the culmination of decades of planning, engineering, and immense human effort, standing as modern-day wonders of the world. From the sprawling plains of South America to the dramatic gorges of Asia, these dams represent humanity's most audacious engineering achievements. They are symbols of national pride and engines of progress, fundamentally altering the course of rivers that have flowed for millennia. Each one tells a story of a nation's quest for energy independence, for security from devastating floods, and for the promise of economic development. They are colossal, complex, and often controversial, embodying the profound relationship between human civilization and the natural world we inhabit. Join me as we explore these 10 engineering marvels. We will journey down the length of the Yangtze, across the vast expanse of the Paraná, and into the heart of the Amazon. We will uncover how these colossal structures function, the incredible power they generate, and the far-reaching impact they have on millions of lives and the environments they transform. This is the story of how we have harnessed the relentless flow of water to power our modern world, a story of ingenuity, ambition, and consequence on a planetary scale. Our journey begins here, on the Yangtze River in China, at the site of the most powerful hydroelectric dam ever constructed, the Three Gorges Dam. The scale of this project is almost beyond comprehension, stretching over 2.3 kilometers across the river. This gravity dam is a monumental barrier, a concrete mountain range forged by human hands. To stand in its presence is to feel the immense weight of its purpose and the incredible power it holds in check. It is, by every measure, the undisputed king of dams, a structure so vast it has become a landmark visible from space. The primary purpose of this colossus is, of course, the generation of electricity. Its 34 enormous turbines, each weighing thousands of tons, work in concert to produce a staggering 22,500 megawatts of power. This clean, renewable energy is a cornerstone of China's efforts to fuel its booming economy and reduce its reliance on fossil fuels. The thrum of the generators is a constant, powerful hum, the sound of a river's energy being converted into light and industry for hundreds of millions of people, a testament to the nation's technological prowess. But the dam's significance extends far beyond power generation. For centuries, the Yangtze was a bringer of both life and death, its devastating floods claiming countless lives and destroying entire communities. The Three Gorges Dam was conceived as a great shield, designed to tame these catastrophic deluges. By carefully managing the flow of the river, the dam has dramatically reduced the risk of downstream flooding, providing a new sense of security to the tens of millions who live along the river's lower reaches. Furthermore, the creation of the dam transformed the Yangtze into a more navigable waterway. By raising the water level and submerging treacherous rapids, it created a deep, placid channel stretching for hundreds of kilometers upstream. This has unlocked the economic potential of China's interior, allowing larger, ocean-going vessels to travel deep into the heart of the country. The river, once a wild and unpredictable force, has become a vital commercial artery, a highway for trade and development. The Three Gorges Dam is a structure of superlatives. It is the largest, the most powerful, and one of the most controversial engineering projects in human history. It represents a profound intervention in the natural world, a decision to fundamentally alter the character of one of the planet's great rivers. It stands as a powerful symbol of humanity's ability to execute projects of unimaginable scale, forever changing the relationship between a nation and its most iconic waterway. We travel upstream from the Three Gorges, along the Jinsha River, a major tributary of the Yangtze, to find our next marvel, the Baihetan Dam. Though second in power, it is in many ways at the forefront of hydroelectric technology. This is not merely a wall of concrete, it is a finely tuned instrument of immense proportions. Rising nearly 300 meters from the riverbed, it is one of the tallest dams in the world, its elegant double-curvature arch design a masterpiece of engineering efficiency, using the natural strength of the canyon walls to hold back a colossal reservoir. At the heart of Baihatan's power are its 16 generating units. These are no ordinary turbines. They are the world's first to achieve a capacity of 1 million kilowatts each. This represents a significant leap forward in hydroelectric technology, allowing for greater power output with a more compact and efficient design. The precision required to manufacture and install these behemoths is extraordinary. They are the pinnacle of modern turbine engineering, turning the river's flow into a torrent of clean energy with unprecedented efficiency. The dam's total installed capacity of 16,000 megawatts makes it a critical component of China's ambitious energy strategy. It is a key player in the country's west-to-east power transmission project, sending vast amounts of electricity from the resource-rich west to the power-hungry industrial centers of the east. This vast transfer of energy helps to power cities and factories thousands of kilometers away, forming a vital artery in the nation's circulatory system of power and significantly contributing to its goals for a low-carbon future. The construction of Baihatan in the deep, narrow gorges of the Jinsha River was an immense challenge. Engineers had to contend with complex geology and the sheer logistical difficulty of working in such a remote and rugged landscape. The use of low-heat cement was crucial to prevent cracking in the massive concrete structure as it cured, a testament to the advanced materials science employed in its creation. The dam is a showcase of cutting-edge construction techniques, pushing the boundaries of what is possible in such a demanding environment. Baihatan stands as a symbol of the new era of dam building. It is smarter, more efficient, and built with a level of technological sophistication that was unimaginable just a few decades ago. It represents the ongoing evolution of hydroelectric power, a continuous quest for greater efficiency and power from the timeless flow of water. As the world seeks cleaner energy sources, projects like Baihatan demonstrate the enduring potential of harnessing the planet's great rivers, albeit on a scale that continues to stagger the imagination. Our journey now takes us to South America, to the border of Brazil and Paraguay, where the mighty Paraná River is harnessed by a true giant, the Itaipu Dam. For many years, this was the most powerful dam on Earth, and it remains a staggering feat of engineering and, perhaps more importantly, of international cooperation. The name Itaipu means the sounding stone in the local Guarani language, a fitting name for a structure that has resonated with power and partnership for decades. Itaipu is a binational entity, jointly owned, built, and operated by Brazil and Paraguay. This collaboration is written into the very fabric of the dam itself. The power plant is a mirror image, with 10 turbines serving the Paraguayan grid and 10 serving the Brazilian grid, each side operating on a different frequency to match their respective national standards. This intricate arrangement stands as a powerful symbol of how two nations can come together to achieve a goal that would be impossible for either to accomplish alone. With an installed capacity of 14,000 megawatts, Itaipu's impact on the energy landscape of both countries is profound. It provides around 15% of Brazil's total electricity consumption and an astonishing 90% of Paraguay's. For Paraguay, the dam has provided not just energy security but a vital source of revenue from selling its surplus power to its much larger neighbor. It is the economic lifeblood of a nation, a concrete and steel foundation for modern development and prosperity, all powered by the relentless flow of the Paraná. The dam itself is a complex of different structures, including a main concrete hollow gravity dam, rock-filled dams, and an earth-filled dam stretching for nearly 8 kilometers across the valley. Its spillway, with its 3 massive chutes, is a spectacle of raw power. When opened, it can release a volume of water 40 times greater than the average flow of the nearby Iguazu Falls. It is a necessary safety valve, but also a breathtaking display of the immense forces that the dam is designed to control. Itaipu has become more than just a power plant. It is a source of immense national pride for both Brazil and Paraguay, and a major tourist destination. It represents a successful model for large-scale, cross-border infrastructure projects. For decades, it has reliably generated vast quantities of clean energy, setting records for annual power production and demonstrating the long-term potential of hydropower. It is a testament to peace, partnership, and the shared ambition to harness a great river for the common good. We return to China's Jinsha River, downstream from Baihetan, to witness another architectural masterpiece, the Ziluodu Dam. This is a structure defined by its elegance and immense height. As a double-curvature arch dam, it stands at 285.5 meters tall, making it one of the tallest of its kind in the world. Its slender curved design is not just for aesthetic appeal. It's actually a marvel of structural efficiency, expertly channeling the immense pressure of the water into the solid rock of the canyon walls on either side. Ziluodu plays a crucial role in a grander scheme of river management. It's part of a cascade of dams on the lower Jinsha, working in concert with other projects like Baihetan and Wudongde. This integrated system allows for a much more sophisticated control of the river's flow. By regulating the release of water from its massive reservoir, Ziluodu helps to reduce sediment buildup downstream at the Three Gorges Dam, extending its operational lifespan and ensuring the long-term stability of the entire Yangtze River control system. With an installed capacity of 13,860 megawatts, Ziluodu is a powerhouse in its own right. Its 18 primary turbines contribute a significant amount of clean energy to China's grid, further bolstering the west-to-east power transmission project. The dam's ability to store and release water allows it to generate power reliably, helping to balance the intermittent nature of other renewable sources like wind and solar. It acts as a giant battery, providing stability and security to one of the world's most complex energy networks. The construction of Ziluodu was a formidable undertaking, set within a region of high seismic activity and complex geological formations. The engineering challenges were immense, requiring advanced seismic-resistant designs and meticulous geological surveys to ensure the dam's safety and stability. The successful completion of the project in such a challenging environment is a testament to the advanced capabilities of modern dam builders and their ability to overcome the formidable forces of nature. The Ziluodu Dam is more than just a power station. It's a key regulator, a linchpin in the intricate system designed to manage the mighty Yangtze and its tributaries. It showcases the strategic thinking behind China's hydropower development, where individual projects are designed not in isolation, but as interconnected parts of a much larger whole. It is a soaring arch of concrete that represents control, stability, and the pursuit of a sustainable energy future on a truly massive scale. Our journey takes us deep into the heart of the Amazon basin in Brazil, to the Xingu River, the site of one of the most complex and controversial dams ever built, the Belo Monte Dam Complex. This is not a single towering wall but an intricate system of canals, dikes, and reservoirs designed to generate power while minimizing the area flooded. Its innovative run-of-the-river design diverts a portion of the river's flow through its powerhouses before returning it downstream, a fundamentally different approach from the massive reservoir dams we've seen so far. The primary goal of Belo Monte is to provide clean energy to millions of Brazilians. With an installed capacity of 11,233 megawatts, it is a giant of hydropower, a critical piece of infrastructure designed to meet the growing energy demands of Brazil's population and industry. The project harnesses the immense power of the Xingu River's Big Bend, a section where the river drops significantly in elevation, creating a natural powerhouse that engineers sought to tap into with this unique and sprawling design. However, from its very inception, the Belo Monte project has been engulfed in controversy. Environmental groups and indigenous communities have fiercely opposed its construction, arguing that it would have devastating impacts on the unique and fragile ecosystem of the Xingu River. The diversion of the river's flow has drastically altered the natural flood pulse, affecting fish stocks and the livelihoods of local communities, particularly the indigenous peoples who have depended on this river for generations. The debate surrounding Belo Monte highlights a central dilemma of our time: the conflict between the need for renewable energy and the imperative to protect pristine natural environments and the rights of indigenous peoples. The dam's proponents point to its significant contribution to reducing Brazil's carbon emissions by replacing fossil fuel power plants. Its critics, however, argue that the environmental and social costs are simply too high, questioning whether the energy produced justifies the irreversible damage to a vital part of the Amazon. Belo Monte, therefore, stands as a powerful and complicated symbol. It's a showcase of innovative engineering, designed to lessen the environmental footprint of a massive hydropower project, Yet it is also a stark reminder of the profound and often painful trade-offs involved in such large-scale developments. It forces us to ask difficult questions about what we value, how we define progress, and whose voices are heard when we decide to reshape the natural world to meet human needs. We now fly to Venezuela, to the Caroni River, home of the Simón Bolívar hydroelectric plant, more commonly known as the Guri Dam. For decades, this colossal structure has been the cornerstone of Venezuela's energy system, a source of immense national pride and a symbol of the country's mid-20th century modernization and ambition. Completed in stages over more than 20 years, its sheer size and output have long made it one of the most significant dams on the planet. With an installed capacity of 10,235 megawatts, the Guri Dam has historically provided the vast majority of Venezuela's electricity. The lights of Caracas and the machinery of its industries have, for many years, been almost entirely dependent on the power generated here, deep in the country's interior. This reliance has made the dam not just an economic asset, but a strategic one, the veritable heartbeat of the nation's infrastructure, pumping electrical lifeblood across the country through a vast network of transmission lines. Behind the 1,300-meter-long gravity dam lies the Guri Reservoir, one of the largest man-made lakes in the world. This immense body of fresh water covers over 4,000 square kilometers, a vast inland sea created by the damming of the Caroni. While its primary purpose is to feed the dam's 20 massive turbines, the reservoir also plays a crucial role in regional flood control, absorbing the heavy seasonal rains and regulating the river's flow, protecting communities downstream from the destructive power of uncontrolled floods. In recent years, however, the Guri Dam has become a symbol of Venezuela's struggles. Severe droughts, linked to changing climate patterns, have at times caused the reservoir's water level to drop to critically low points, threatening a nationwide power collapse. The country's over-reliance on this single source of power, coupled with a lack of investment and maintenance, has highlighted the vulnerabilities of depending so heavily on hydropower in an era of increasing climate uncertainty. The story of the Guri Dam is therefore a tale of two halves. It's a story of immense achievement, of a nation successfully harnessing its natural resources to power its development. But it is also a cautionary tale about the need for diversified energy sources and resilient infrastructure. It reminds us that even the mightiest of structures are subject to the whims of the natural world, and that the responsible management of these great assets is just as important as their initial construction. We return once more to the powerful Jinsha River in China to find the Wudongda Dam, the youngest marvel on our list and a beacon of modern engineering. Situated upstream from Baihetan and Ziluodu, Wudongda is another stunning double-curvature arch dam, soaring 270 meters high. But its true innovation lies not just in its impressive stature, but in the intelligence embedded within its very structure. It has been called a smart dam, representing the next generation of hydroelectric projects. This intelligence comes from a comprehensive real-time monitoring system with thousands of sensors embedded throughout the concrete. These sensors constantly measure temperature, stress, and strain, providing engineers with an unprecedentedly detailed picture of the dam's health and performance. This data allows for predictive maintenance and ensures the structure's long-term safety and stability, especially given its location in a seismically active and geologically complex region. It is a structure that feels and reports on its own condition. With an installed capacity of 10,200 megawatts, Wudongda is another powerhouse in the cascade system of the Jinsha River. Its 12 generating units add a massive amount of clean energy to the grid, contributing significantly to the west-to-east power transmission project. Its primary function, like its neighbors, is to help China meet its immense energy needs while simultaneously working towards its ambitious carbon neutrality goals. It is a key weapon in the country's fight against climate change. A significant achievement in Wudongda's construction was the use of low-heat cement on an unprecedented scale. In massive concrete structures, the chemical reaction of curing generates immense heat, which can cause cracking and compromise the dam's integrity. The development and application of this special cement, which produces far less heat, allowed for a faster, safer construction process, and resulted in a stronger, more durable final structure. This materials science innovation was critical to the project's success. Wudongda represents the cutting edge of dam construction. It combines elegant design, immense power, and sophisticated intelligent monitoring systems, It is a testament to the continuous innovation in the field, demonstrating that even a technology as old as dam building can be reinvented for the 21st century. It stands not just as a barrier to hold back water, but as a complex data-driven system designed for maximum efficiency, safety, and longevity in the service of providing clean, reliable power. Our travels take us back to Brazil, but this time to the Tocantins River, a major waterway in the eastern Amazon region. Here stands the Tucuruí Dam, the first large-scale hydroelectric project built in the Brazilian rainforest. For a time, it was one of the most powerful dams in the world, and it remains a critical component of Brazil's renewable energy matrix. Inaugurated in the 1980s, Tucuruí was a bold statement of Brazil's intent to develop its vast interior and harness its immense natural wealth. With a current installed capacity of 8,370 megawatts after a second-phase expansion, Tucuruí is a workhorse of the Brazilian power grid. Its primary purpose was to supply energy for major industrial projects, particularly aluminum smelters, which are incredibly energy-intensive. By providing a vast and reliable source of electricity, the dam spurred significant economic development in a previously remote and undeveloped region. Fundamentally altering the economic geography of northern Brazil, the construction of the dam created the Tucuruí Reservoir, a sprawling artificial lake covering approximately 2,850 square kilometers. This vast body of water not only feeds the dam's 25 turbines but has also created new opportunities for navigation and transportation. A system of locks, one of the largest in the world, was built to allow vessels to bypass the dam, creating a navigable waterway that connects the region to the Atlantic Ocean and facilitates the transport of agricultural and industrial goods. Like other dams in the Amazon, Tucuruí was not without its environmental and social consequences. The creation of the reservoir flooded a large area of tropical rainforest and displaced thousands of people, sparking significant debate and protest. The project became a learning experience for Brazil, highlighting the need for more thorough environmental impact assessments and better mitigation strategies for future large-scale infrastructure projects in sensitive ecosystems. Today, the Tucuruí Dam stands as a monument to an era of ambitious national development. It successfully unlocked the economic potential of a vast region and continues to be a vital source of clean energy for Brazil. At the same time, it serves as a powerful lesson in the complexities of development in the Amazon, a reminder that the pursuit of economic growth must be carefully balanced with environmental stewardship and social responsibility. It is a powerful engine of progress, with a complex and enduring legacy. We now travel to the United States, to the Great Columbia River in Washington state, to visit a dam that is not just a power plant, but a piece of living history, the Grand Coulee Dam. Conceived during the depths of the Great Depression, this dam was a monumental public works project, a symbol of hope and resilience that put thousands of Americans to work and transformed the American West. It is the largest hydroelectric facility in the United States and a legend in the world of engineering. The Grand Coulee Dam is a concrete gravity dam of immense proportions, containing nearly 12 million cubic yards of concrete. When it was completed, it was the largest man-made structure in the world. Its purpose was threefold: to provide hydroelectric power, to control the often destructive floods of the Columbia River, and, perhaps most ambitiously, to provide irrigation for the arid lands of central Washington. With an installed capacity of 6,809 megawatts, it remains the heavyweight champion of American hydropower. The dam's role in irrigation is truly remarkable. Its powerful pumps, some of the largest ever built, lift water 280 feet up from the reservoir, Lake Roosevelt, into a feeder canal that flows into a vast network of channels and aqueducts. This system, the Columbia Basin Project, has turned over 500,000 acres of desert into fertile farmland, creating an agricultural oasis in a region that was once little more than sagebrush. It literally made the desert bloom, a testament to the transformative power of water. During World War II, the Grand Coulee Dam played a critical, if unsung, role. The immense amount of electricity it produced was used to power the aluminum smelters and plutonium production facilities that were essential to the war effort. The dam was, in effect, a vital component of the arsenal of democracy, its clean, abundant power helping to forge the tools of victory. Its historical significance is therefore woven into the very fabric of the 20th century. Today, the Grand Coulee Dam continues its work, generating clean power, preventing floods, and watering farms. It stands as a testament to the vision and ambition of a previous generation, a structure that reshaped a region and helped win a war. It is an icon of American engineering, a concrete giant on the Columbia that demonstrates how a single project can fundamentally alter the landscape, the economy, and the course of history for an entire nation. Our final destination takes us back to China, to the Hongshui River, a tributary of the Pearl River system. Here we find the Longtan Dam, an extraordinary example of modern engineering and a giant in its own right. What makes Longtan particularly special is its construction method. It is the world's tallest roller-compacted concrete gravity dam, a technique that allows for rapid, efficient, and strong construction on a massive scale. The roller-compacted concrete method involves laying down concrete in thin, dry layers, which are then compacted by rollers much like paving a road. This technique allowed the Longtan Dam, which soars to a height of 216.5 meters, to be built far more quickly than if traditional concrete pouring methods had been used. The dam contains over 7.5 million cubic meters of RCC, a testament to the efficiency and scale of this advanced construction process. It represents a significant evolution in the art of building gravity dams. With an installed capacity of 6,426 megawatts, the Longtan Dam is a major power producer for southern China. Its 9 large turbines generate a vast amount of electricity, feeding the rapidly growing industrial and urban centers of the Pearl River Delta. It plays a vital role in the region's energy security and economic development, providing the clean power needed to fuel one of the world's most dynamic economic zones, while also reducing the reliance on coal-fired power plants. Beyond its power generation, the dam serves a crucial flood control function for the downstream areas along the Hongshui and Pearl Rivers. Its large reservoir can hold back enormous volumes of floodwater, protecting millions of people and valuable economic assets in cities like Guangzhou. The dam also incorporates a unique 2-stage ship lift system, an engineering marvel in itself, designed to transport vessels up to 500 tons over the massive structure, maintaining navigation on the river. The Longtan Dam is a powerful finale to our journey. It showcases how innovative construction techniques can be used to create colossal structures with greater speed and efficiency. It is a workhorse, quietly and reliably performing its multiple duties of power generation, flood control, and navigation. It stands as a symbol of China's continued mastery of large-scale hydro-engineering, a roller-compacted concrete giant that secures the prosperity and safety of an entire region. Our journey through the world of colossal dams comes to an end. From the record-shattering power of the Three Gorges to the historical significance of the Grand Coulee, these 10 structures are more than just concrete and steel. They are magnificent showcases of humanity's remarkable ability to harness the fundamental forces of nature. They demonstrate our capacity for grand vision, intricate engineering, and monumental construction, transforming water resources into clean energy, providing security from floods, and catalyzing development on an immense scale for millions of people. These engineering marvels have fundamentally reshaped our world, but their legacy is complex. As we look to the future, the conversation around such projects continues to evolve. The urgent need for clean energy to combat climate change keeps large-scale hydropower as a compelling option. Yet, we are more aware than ever of the profound environmental and social costs that can accompany these developments. The challenge for the next generation of engineers and policymakers will be to navigate this difficult terrain with ever greater wisdom and foresight. The story of dams is the story of our relationship with the planet's lifeblood water. The ongoing task is to find a sustainable equilibrium, a way to meet our escalating needs for energy security while honoring our duty to preserve the delicate ecosystems and diverse cultures that depend on the world's great rivers. The future will demand not just bigger and more powerful structures, but smarter, kinder, and more integrated solutions that balance the needs of humanity with the health of the natural world.